Okay, this is Math 2, Unit 8, Lesson 3, Simplify Exponential Expressions. This will be the start of the packet 2 that you'll be getting at the end of class. Okay, first section is pretty easy. Fill in the blanks. Number 1, x to the 4th times x to the blank equals x to the 6th. Right, because when we're multiplying like bases, what do we do with the exponents? You add. And so 4 plus what is 6? You guys just told me it is 2. Do we all agree? Okay, number 2. X to the 13th times x to the blank equals x to the 5th. So same as the last one, 13 plus what number equals 5? Is that going to be a positive or a negative? Do you guys agree it has to be negative? Why is that? Because 5 is smaller, so it has to be 13 plus a negative number to give me the 5. You can do it in your head. You can subtract the 13 from 5. Anybody have it? What is it? Negative 8. Okay. Number 3, x to the blank times x to the 5th equals 1. Why don't you try it on your own? X to the 5th times, I'm sorry, x to the blank times x to the 5th equals 1. On this one? Okay. I heard negative 6. Anyone else? What?
4.
Negative 4. Anyone else? Negative 5. Did anybody get any one of these numbers or something different? 4? Oh, negative 4? 0. Anyone else? Negative 4? Because it's the answer? Yes. Negative 5. Okay, we have another negative 5. Anyone else? Yes. Oh, another negative 5. Negative 4. Last ones. Anyone? Yes. Negative 4. The answer is negative 5.
No.
Oh. Okay. I am going to explain. Okay. I do need you guys listening. Okay. X to the negative 6 times x to the 5. Please stop. What's negative 6 plus 5?
Negative 1.
Negative 1. X to the negative 1, is that the same as just positive 1? No. Okay, let's try x to the negative 4. Guys, it's okay. What's negative 4 plus 5? Which was the most popular answer, but that gives me x to the 1. Am I trying to get x to the 1?
No.
No. Okay, so it's not that one either. I'm going to try the 0 first. X to the 0 times x to the 5. I add those together, what do I get? Is x to the 5 the same as 1?
Nah.
No? Okay, let's try negative 5. X to the negative 5 times x to the 5. You add those together, what does that give you?
0.
X to the 0. And is x to the 0 the same as 1?
Yes.
Yes. Do you see that?
No.
Okay, so what you have to think about right here is like, hey, wait a minute. That's not a base of x, but then in your head you think, oh, x to the 0 is the same as 1. And then what plus 5 is 0? And what is it?
1.
Negative 5.
Negative 5.
Yes.
So basically anything with the 0 is 1?
Unless the base of 2. I'm sorry, the base of 0 won't work, but anything else will. anything to the 0 except for 0. So 1,000,000 to the 0 power is 1. All right. Are we good?
Yes.
All right. Next section, we are going to find the value of x.
Find the value
Find the value of x. Number 1, the 5th root of 7 cubed times 7 to the 1/5 equals 7 to the x over 5. There are quite a bit of these on the test.
Did we do it?
We have. Good. I'm so glad you said that. He said, have we done these already? Yes, we have. So this little section right here is review. Actually, all of this is review. They're just some harder type problems. Okay. No. First off, do they all have the same base?
No. Yeah.
7,
Yeah.
7, and 7. I'm going to cover this side. This is multiplication. When multiplying like bases, I add the exponents. What will I have to do to this one first?
You had to break. Wait, no. Wait, you have to do
Change it to,
fraction.
it's already radical form. Change it to
Fraction.
exponential form. 7 to the 5/3 or 3/5.
3/5.
Now, they're nowhere on your homework, on your quiz, or your test is going to say, hey, change that to exponential form first. You just need to know that. Why? Because you want to do what with these exponents? You want to add them.
7 to the 4th.
Close. In order to add, I need a common denominator. Please pay attention.
5.
Is the denominator already the same?
Yeah.
So what does that become? X to the, 7 to the 4/5 equals 7 to the x/5. First off, the bases have to be the same, are they? Okay, so what does x have to be in order for these two to be the same? X is 4. 7 to the 4/5 would equal 7 to the 4/5. Do you see that?
So it has to be 7 to the 4th and equal to 7 to the 4th.
X is 4. In order for these two to be equal, x would have to be 4, so that it could be 4 over 5 and 4 over 5. Okay? What if I gave you something like this? 5 to the 4/3 over the 6th root of 5 squared equals 5 to the x.
Just turn the.
Okay.
5 to the second.
Okay, he said change this 5 to the 2 over 6. I'm going to take his advice. 5 to the 4/3 over 5 raised to the 2 over 6. Now, what did I do on this one with the exponents? I
Oh, it's a problem.
added. What am I going to do here? Be careful, it's not division. Subtract. I had a kid say, hey, wait a minute. When dividing fractions, don't you multiply by the reciprocal? Yes. But am I dividing fractions here? No. Do you see the difference? I'm dividing the 5s, which means I'm going to subtract the exponents. You do need to know the difference. It's right here in our notes. When dividing like bases, you subtract the exponents. Do you guys remember that? Yes. You need to be paying attention. All right. In order to add or subtract, we need a common.
Denominator.
Is there already a common denominator?
No.
Is there?
Yeah.
This one there was 5 and 5, but this is 3 and 6. Are they already the same?
No.
No. So you do 4/3, take away 2/6. And you thank your elementary school teachers for teaching you how to add and subtract fractions. I could reduce the 4th, or I'm sorry, I can reduce the 2/6, but I'm just going to change it to 6 since that's what most of you guys would probably do. 2 is going to stay 2. And what do I multiply top and bottom by here? 2 to get, because 3 times 2 is 6, 4 times 2 is 8. And then I do 8 take away 2, and 6 stays the same. What's 8 take away 2?
6.
And 6 over 6 is 1. You do want to check what your exponent on the second one looks like. For example, if this was written as blank over 6, leave it as 6 over 6. But since it's written as just x, I'm going to change that to 1. 5 to the x just came down. 4/3 take away 2/6 is 1. What does x equal? 1.
Where do you find that first?
5 to the first right here. 6 over 6 equals 1.
Ah, yeah.
And that came from 4/3 take away 2/6. Questions? No questions? Okay. We are going to move on to simplify.
Simplify.
Okay. Simplify. All right. Number 1, I'm going to put A versus B. This is the one we've been talking a lot about. Like, this is at least the 3rd day in notes that we've talked about this type of problem. 3x close parentheses negative 2 versus 3x to the negative 2. When I first talked about this, I asked you guys, does that parentheses make a difference? Yes. Can anybody tell me anything about A or B? Yes.
For A, the 2 applies to both of them.
Okay, he said for A, the negative 2 applies to both, and B, the negative 2 only applies to the... So I'm going to do this one first then. What moves to the bottom?
The
X squared.
X squared, and what stays at the top? 3. Do you guys all agree? Any thoughts or suggestions on A? Anyone want to share how to do part A?
distribute the thing.
Okay, distribute the exponent. I need to put some ones in there.
So they're at 3. Yeah.
Yes. What about the x?
Yeah.
The x has no exponent either, so he's saying put ones on both.
Yeah, that.
All right. Do I do 3 times 1 or, I'm sorry, 3 times negative 2 or 1 times negative 2? So 3 raised to the negative second times x raised to the negative same to the negative second. 1 times negative 2 is negative 2. Now, are they both moving or just one? They're both negative. So 3 squared, x squared. This time what stays at the top if they both moved? 1. So 1 over what's 3 squared? 9x squared is the final answer. So do you see how they are different? 1 over 9x squared, 3 over x squared, there is a difference. All right, questions?
Does the number always move with the x?
Can anyone answer that? Does the number always move with the x? It depends on what? Not the negative, but the parentheses. If there's parentheses around it, yes. See how this one had no parentheses, so it stayed at the top. Do you see that? Okay. Number 2. 2y, and I'm going to put 2y squared, raised to the 4th power over parentheses 6y close parentheses 2nd power. Need some ones. He is correct. On the 2, on what else? 6 and the, and are we ready now to distribute? Will I multiply 2 times 4 or 1 times 4?
1 times 4.
Okay, so 2 raised to the 4th and y raised to the 8th. And then 6 raised to the 2nd and y raised to the 2nd. Okay. 2 to the 4. Oh, can I subtract these 2 exponents?
Yeah. Wait. Yeah. No.
No, because the bases are not the same. I can subtract these. Okay, so it's 8 subtract 2, not 8 divide by 2. Let's clean these up first. What's 2 to the 4th?
The
2 times 2 is
4.
4 times 2, 8. 8 times 2 is
16.
16 y to the 8th, and then 6 squared is 36 y squared. Now, the question I have for you, Isaac already told us we're going to subtract the 8 and the 2. Do you guys agree with that? So, does that mean I should also subtract the 16 and the 36?
No.
No. I have a lot of kids that do that. What's the difference? The 8 and the 2 are exponents. The 16 and the 36 are bases. Do you see the difference? So, do I subtract the 8 and the 2?
Yeah.
Yes. Do I subtract the 16 and the 36?
No.
No. I just reduced that like you would back in elementary school. What goes into 16 that also goes into 36?
6.
4. 16 divided by 4? 36 divided by 4. Now those are perfect squares, but you can't reduce them. Nothing goes into 4 that also divides into 2. All right, 8 take away 2, there's more at the top, so y to what power? 6. Make sense?
Yeah.
Would it have been okay if I reduced the 2 and the 6 first?
Yeah. Right? Wait, no.
Why not? Because they each have individual
They're
powers. So I have to distribute first. I have to do with the exponents first before I reduce. Got it? All right, number 3. 6x y negative 3 over negative 2 x to the negative 2 y to the negative 1 is correct. Now, at least in this class I haven't gone over it with you, but you may have learned it or talked about this in last year's math class, in Math 1. Negative exponents move to the bottom. Do you guys agree this is going to move to the bottom?
Yeah.
What happens when they're already at the bottom? Where do they move to?
Side.
They don't move to the bottom. They move further to the bottom. Is that what somebody said? Further to the bottom is correct. And further to the bottom, when you multiply by the reciprocal, ends up moving them to the top. So top goes to bottom and bottom goes to top. Okay, before I move, the 6 and the negative 2, will I subtract those or reduce those? Reduce. That's not a subtraction problem. What's 6 reduced by negative 2? Negative 3. Okay, do you guys want to reduce that now or later?
No.
Now. Okay, negative 3 over. Okay, let's see what's happening. I already reduced those two guys. From what's left, what is the only thing that's not circled? The x, so it's going to stay put. Everything else is moving. The y to the negative 3 is going to the bottom. The x to the negative 2 is becoming x squared at the top, and y to the positive 1 at the top.
Why did it become
This x stayed put. I'll put a little 1 there. X to the 1 stayed put. X to the negative 2 was at the bottom. It joined the top. Y to the negative 1 joined the top. And y to the negative 3 joined the bottom, all becoming positive. What do I do with these guys? Add or subtract? So negative 3x to what power? Third. What do I do with these guys? Add or subtract? More at the top or the bottom? Y cubed, so it's going to end up at the bottom. What's 3 take away 1? So y squared. Negative 3x cubed over y squared. Yes? Yes, you may. Okay. Really quick, guys. Make sure you understand when things move around. Yes?
So if you subtracted 1 by 3, wouldn't that make it negative 2?
If you subtracted...
Oh, no.
You got it? Were you able to do it? Does anyone want to address the question he asked? He figured it out. Does anyone else want to see it? No? We're good?
No.
Yes? Okay. I won't show it. What he was asking about, what if I did subtract negative 3 minus negative 1? What would have happened? Okay. Now, can anybody explain why Do you see the original problem had x at the top and y at the top, x at the bottom and y at the bottom?
Yeah.
But when I rewrote it, all the x's were at the top and the y's some at the top and some at the bottom. Can anyone explain why the y's ended up top and bottom but all the x's were at the top? Anybody know?
Why is that?
Was that x negative? Exponent.
No.
Did it move?
No.
No, but that one was, so it joined it. So does that put any x's at the bottom?
No.
No. Sometimes everything flips, sometimes things stay. You just have to pay attention to the problem. Let's try another one. Number 4. 3 x to the negative 5, y to the negative 2, bless you, 21 x to the negative 8, y to the negative 9. And I'm going to make this right here a negative 3. Actually, I'm not. I apologize. Okay. Let's take a look. Do I have negative exponents?
Yeah.
Yes or no?
Yep.
Okay. I'm going to reduce later. I know on this last one I reduced first. I'm going to reduce later. I'm going to cover this. The 3 and the 21. Are those going to flip-flop? Does anything move? No. Even, I'm going to put it in pencil because I will erase. Even if I had a negative sign there, should that move to the bottom?
No.
No, because that's not a negative exponent. Keep that in mind. Okay, so when I do this, I'm going to circle all the negative exponents. Is x to the negative 5th going to move?
Yeah.
Is y to the negative 2 going to move?
Yes.
X to the negative 8? Y to the negative 9? So pretty much are the x flip-flopping and the y's flip-flopping?
Yeah.
Does that always happen?
No.
No, over here the y's flip-flop but not the x's. Sometimes the x's but not the y's. Sometimes none, sometimes all. It just depends on the problem. 3 is staying, 21 is staying. The x's are switching places, becoming positive. The y's are switching places, becoming positive.
Yeah, that always becomes-
There most of the time will be something moving, but they don't always flip-flop. Sometimes A stay, sometimes B's move, or X's, and so forth.
Yeah.
Okay, 3 and 21, subtract or reduce?
Subtract. Wait, no. Reduce.
Reduce. What goes into 3 that also goes into 21?
3.
3 is 1 and 21 is 7. All right, so I have 7 at the bottom. I don't know if I have to put that 1 yet. Let's check. X's. What do I do? Subtract?
Exponent.
Subtract the exponents. 8 take away 5 is
3.
x cubed at the top or bottom? Y? That's the bigger number. Okay, y's. 9 take away 2 is what? Top or bottom?
Top.
Top. I don't need to put the 1 up there. If there was nothing left at the top, I would have to put that 1. But since the x cubed and the y to the 7 stayed, if you put the 1 in front, it's okay, but you don't have to. That there is your final answer.
That's crazy.
It is. Shall we try one more like this?
No.
No, you guys have got the hang of it?
Yes.
So, question again. Is everything always going to flip-flop?
No.
No. Sometimes it does, sometimes it doesn't. Let's try a different type of problem. Number 5. 3x to the 4th power over 2y to the 5th power, big parentheses, negative 3.
You gotta put a 1
You are correct. Put a 1 on the 3 and what else?
and the 2.
And the 2. And because there's big parentheses, what do I do with the negative with the negative exponent?
Distribute.
Distribute to everything?
Yeah.
Yes. All right. So I don't do 3 times negative 3. I do 1 times negative 3. So it's 3 to what power?
Negative.
X to what power once I multiply?
Negative.
Good job. Over 2 times negative 3 or 1 times negative 3? 1. So 2 to the negative third and y to what power?
Negative 2.
All right. We're going to circle negative exponents. Is everything negative in this case?
Yeah.
So everything's going to flip-flop. That's moving to the bottom, that's moving to the bottom, and these two are moving to the top. Why did this -2 not move? I left him down there and just reduced, but why are these two guys moving? Because they have negative exponents. All right, so when I switch things around, it becomes positive. 2 cubed, y to the 15th. 3 cubed, x to the 12th. Can we simplify the 2 cubed into 3 cubed?
Yes.
2 cubed is 2 times 2 times 2, which is what? 8. Y to the 15th. 3 times 3 is 9. 9 times 3 is 27. X to the 12th. Can I subtract the 15 and the 12?
No.
Why not? The bases are not the
Same.
same. Should I subtract the 8 and the 27?
No.
No, I can try to reduce. Does anything go into 8 that also goes into 27? No. That there is your final answer. Any questions?
Nah.
Did I hear a wait? No?
Nah.